Hi everyone, today I would like to introduce the integration by part. So, what is integration by part? Let me explain what is integration first. Integration is the process of finding the antiderivative, and we always denote that fx is the antiderivative of fx. So f pi x is equal to fx, and integration by part is a technique of integration based on the product rule for differentiation. So, when do we use integration by part? When we do integration, always use integration by substitution as you can, which means substituting the quantity in a given interval. For example, to calculate the integral of 3x plus 5 to the 7th power with respect to x, we need to let u be 3x plus 5. Then, sub u into the function, so we get the integral of 1/3 times u to the 7th power instead. And it will simply become the integral of 1/3 times 1/x times u to the power x plus c. After the calculation, we'll get that 1/24 times u to the power x plus c. Then subtract the 3 plus 5 and we will get the answer. However, there are some functions we can't use integration by substitution. For example, the integral of x squared log x dx. Then we need to use the integration by parts. So let me explain how this powerful technique works. Integration by parts is based on a product rule for differentiation. In particular, if ux and vx are both differentiable functions of x, then the derivative ux vx will be equal to ux times the derivative of v with respect to x, and vx times the derivative of u with respect to x. And changing the pairs, we'll finally get the formula. The integral u dv equal to uv minus integral v dv. Let's do one example. To integrate x squared log x with respect to x, we need to choose a u. And here is a hint for choosing u. We choose u to be the portion of intervals whose derivative du is a simpler function than u itself. In this case, we will choose u equal to log x, as du equal to 1/x dx, which is simpler than log x itself. Then dv equal to x squared dx. And by integration, v equal to 1/3 x cubed. And we can use the formula. Integrate u dv equal to uv minus integrate v du. So it becomes log x times 1/3 x cubed minus integral of 1/3 times x cubed times 1/x dx. And as you can see, you simply get the answer. And remember to add the part c in the answer. On the other hand, integration by parts can also apply on definite intervals. Integration can be used to find the area under curve. So definite interval does. Here is the formula. The integral of u du from the range a to b is equal to uv relative from a to b minus the integrals of v du from a to b. And it helps us to calculate the area under the function within the given range a to b. For example, the function y equal to log x, the integrate log x dx from range a to b means the area shape under the curve. Let's try to calculate. Let u equal to log x and dv equal to dx. Then we get x log x from 1 to e minus integral of x times 1 over x dx from 1 to e. And it will simply become x log x minus x, whereas the whole thing from 1 to e. Then, by popping the e and 1, we'll get e log e minus 1 log 1 minus 1. And we'll get the answer. So I hope all of you understand this topic. And here are the exercise. The first one is a simple and straightforward question. And the second one is more challenging, which needs to use the integration by part choice. And the first question is the definite interval. And the answer are given, so you can try it yourself. Here is the end. Thank you for your watching.